arc sine. Right, what we're going to do is we're going to look at integration by parts and then take a short break. So by parts is basically the kind of reverse process for product rule, okay? But what we actually have to do is out of the product of two things, treat one of them as the derivative of something and one of them as the integral of something. So if I give you an example here for this one, let me just check. We're good to go with this. Yeah. So this one here, we have to, and you might have different ways of denoting this. I'm going to do a more shorthand notation up here. Integral of u v dash is equal to uv minus the integral of vu dash. If you prefer it like that, is that okay? Some people prefer it sort of written kind of that way. Sorry, it's a bit crammed in the top. Now, what we're going to do is we're going to say what's u and what's du dx or u dash. And then we're going to say what's dv dx and what's v. Okay. Right. It does get more complicated than x and e to the 2x. But the first prompt I would say is the easiest thing to set up as the one we differentiate in this particular case is x, because when you differentiate it, it goes to 1. So it's going to make the problem easier. So well done. If you've got the little acronym for that, LIATE or whatever it is, tells you the order. This is pretty much what you're going to choose most of the time. It's only when there's a logarithm you have to look out for it. So u is going to be x, du dx is 1, dv dx is e to the 2x. So just be careful finding v, you have to actually integrate that. So integrating e to the 2x will be a half e to the 2x. So let's do this together. Now, if we sub it into this formula, then what we're going to get is x squared, oh no, sorry. This times this, oh no. Losing the plot here. So x times a half e to the 2x minus the integral of the other way round, which will be 1 times a half e to the 2x with respect to x. Okay, so what we're going to do, we still leave ourselves with an integral to do, but it should be an easier one than the original question. And don't forget, guys, you can pull out the half out the front as here and just do the integral of that and then tidy it up. And what must we not forget? We mustn't forget at the end of it the plus c. So we are going to get, if we go through this together, x over 2 e to the 2x minus, then the integral of e to the 2x is another half e to the 2x. The half times the half is a quarter e to the 2x plus c. Well done if we got that. Hopefully that's all good. So key things, I've kind of written all over the positions here. They're the things we found. And then what we should have, so I'll rewrite that final answer. Oops. Is we got x over 2 e to the 2x minus a quarter e to the 2x plus c. So let's give this a go. One quick practice and then we'll take a break. Here's your question for 5 marks to try by parts. My hint, for those that aren't aware, is we know how to differentiate ln as 1 over x. That will simplify the problem. That's probably how you want to set it up. You are also given a picture of the graph because we're using it to find an area. So it won't be a plus c. it'll be sub some values in. Right, I'm going to give you 2 minutes. We'll check some answers and then we'll take a short break. Here we go. Okay, so we're going to differentiate ln because we know how to do that. And it also will help simplify the problem because the derivative of ln is 1 over x, which will make things hopefully a bit nicer. Okay. So a suggestion here is u is ln x and du dx is 1 over x. That means that the v dash, the dv dx bit, is root x. So we actually then need to integrate that. That's the one tricky bit. So we need to add 1 to the power and divide by the new power. And that's what we're subbing in. Once we've got that, we plug it in simply to the by parts formula, which will be uv minus the integral of v du dx. And what we should find is the v du dx, the 1 over x cancels the x to the 3 over 2 in a nicer way. So this is what we get. We're going to get, and I've just skipped ahead to this part here. Don't worry about the bounds too much. 2/3 x to the 3 over 2 ln x minus the integral of 2/3 x to the 3 over 2 times 1 over x. That will tidy up to the integral of 2/3 x to the half. Now you can do that integration, and then sub the bounds in of e and 1. Okay, so I'll just give you a minute to have a little look at that. And if you sub those bounds in, leave it exact, our final answer is 2/9 e to the 3 over 2 plus 4 over 9. Now I'll give you a minute to look over that. We're actually going to take a short break till just after 3 o'clock, I think we're going, and then we'll be doing our final session on statistics. Look forward to speaking to you then. If you've got any questions, keep them coming in. Really well done. You guys are doing so well today.